Hello and welcome one and all to the first live session of Day 3 of Industry Tech Days 2021. I am Kate Smith, the Editor-in-Chief of All About Circuits, and I am happy to welcome you to this presentation titled Why MQTT-SN, an exploration of the power-saving advantages of MQTT-SN in IoT devices. Today we have two speakers with us. We have Lee Stacy, u-blox Product Evangelist, and Nick Hayes, the Principal Engineer and Product Owner. And before I hand things over to them, let me mention that the Q&A widget at the bottom of your screen here will allow you to submit questions for Lee and Nick at any time during this presentation, and we'll get the chance to go through them live at the end. Let me also mention that this presentation will be made available on demand, and you'll also have the chance to download the slides as well. So finally, we'll announce a giveaway winner at the end of the session, so stay tuned for that. And with all of that said, let's get started. Gentlemen, take it away.
Thank you, Kate. Thank you, everyone, for joining us today to talk about the power of MQTT and the power savings of MQTT-SN. My name is Lee Stacy. I've been working with the Thingstream team as a product evangelist since 2018. And since our acquisition last year, I now work to promote products and services across the whole u-blox range. First, I'll give you a briefish intro to MQTT, and from there I'll hand over to my colleague Nick Hayes, who will give you a live demo and show you how everything works and how you can apply some real power savings. What is MQTT? Firstly, it's defined as a lightweight publish and subscribe message transport protocol that is designed for low network overhead and simple implementation. It typically uses IP as its transport protocol. It's been around since the mid-90s, and within the last few years, maybe last 5 to 10 years, it's kind of become the de facto standard for IoT and M2M communication. That's largely due to its flexibility, efficiency, and of course how easy it is to use. Typically, it uses IP as its transport protocol. One thing I should mention first is that it's not a traditional client and server relationship, but it's actually a client to broker relationship or broker to client relationship. What this means is that messages are not sent from client to client or client to server, but via topics stored on an MQTT broker. These topics, as you'll see from the diagram on the screen, they work kind of like a street address, forming a topic tree that becomes more specific as it branches out. Clients get messages by subscribing to these topics, of which they can subscribe to one or many. The client will receive messages from subscribed topics as well as those that branch out for it. So, for example, if a message is published to the farm topic that you see on the slide there, clients that are subscribed to the farm topic or the topics below it, south, north, moisture, and light, they will all receive a message. Whereas if a message is published to the north topic, only clients subscribed to north, moisture, and light will receive the message. So you see it's a kind of hierarchical structure there. Now, those messages can be published with 3 different levels of QoS, or quality of service, which define the reliability and whether or not delivery receipts will be provided. These levels are QoS 0, where the message will be delivered at least once, at most once. I must get that right, that's important. QoS 1, where it will be delivered at least once, and QoS 2, where the message will be delivered exactly once. Now, MQTT-SN, which I'll come to in a bit, also includes another level, which is -1, which is a completely blind fire and forget message. As I say, I'll come to that a bit more in a little while. What advantage does MQTT bring with it? Well, firstly, its topic structure makes communication really simple. It's really easy to get the message to the devices you want just by sending it to the topics they're subscribed to. Secondly, there's no polling. Push-based delivery means clients don't need to continually poll for messages. That in itself is a power saving there. Dynamic targeting is also made a lot easier by the way topics are structured. There's no need to keep a roster of peers. You simply publish to a topic and all of the clients subscribed will get it. Lastly, MQTT is built for scale, so you can make changes to the network quite easily thanks to the topic structure without sending a ripple effect across the whole system. So while we're talking about the advantages, now's a good time to talk about MQTT-SN. MQTT-SN includes further optimization of the MQTT standard, making it more appropriate for low power environments such as sensor networks. As I mentioned previously, it supports an extra QoS level, -1 for fire and forget messaging. With QoS level -1, the message originator doesn't expect any kind of answer back after sending it. So this reduces time on air and thus reduces the amount of battery required to power the device. So it's ideal for power-constrained devices that need to send frequent updates. These could be sensors out in a moisture farm or something like that. To reduce further data overheads, MQTT-SN also allows for short topic aliases. This means you can have nice logical names for your topics so that you can easily see where your messages need to get to, but you don't have to waste time on air and precious data, including the whole topic name every time. On top of that, MQTT also brings you a sleep mode or a disconnected session that allows messages to queue up on the broker while the subscribed device is powered off. And then, of course, it just switches on, wakes up and sends a message, or rather looks for a message, and it will grab the message straight from the broker. Now, with our Thingstream platform, the u-blox Thingstream platform, we make MQTT even simpler and bring a few more benefits into the mix. I'll touch on those in the next couple of slides, just before handing over to Nick. But first, where does the magic happen? Well, the place where you actually get stuff done is in the data flow manager, the rapid production environment within the Thingstream platform. And that's what it looks like. The data flow manager, it makes it easy to process and transform data. And with that, you can apply logic to data as it travels from devices to platforms. For example, you can apply conditional if this then that style logic, for which there are ready-made modules for you to do that. Or you can even write small programs within the flow to manage or process the data. And on top of that, to speed up integration, we've included a library of pre-built flows and had various third-party application nodes to make connections to services like Microsoft Azure or IBM Watson really simple. And there's also a bunch of other different nodes that can help you perform other functions that you might want to perform on your data as it goes through that flow. Also, it's easy to get your applications from a single subscription prototype into a production environment with auto-scaling instances. Essentially, the platform takes care of all of the scaling for you by invoking a new instance when a flow is required. And those are the basics in a very quick. It's a very quick run through of how it all works. Now I'll hand you over to my colleague Nick, who will give you a live demonstration.
Yeah, thank you very much, Lee. Hello to everybody. As Lee says, thanks for giving us your time today. I'm just going to jump in and show you just how those power-saving benefits in MQTT-SN come about and what they mean. So here on the screen, you can see this is my Thingstream platform. This is where I can control all of my devices. And here I have a device which is using the built-in MQTT-SN client on the u-blox SARA R5 module. The service we have here works across multiple different module types and module vendors, but there's some benefits of the R5 and the R422 having an embedded client, so it just makes things very quick and easy to get up and running. So here I have a little AT terminal, so I can send AT commands to my modem. And I'm just going to start off by connecting to the broker. So this command here is issuing an AT command, connect to the broker. I see now my MQTT client has moved to a connected state, and now I can carry on and start to publish messages. So the next step I need to take is to register an MQTT topic, and I'll do that here. So the topic I'm registering is sensor/heat. So this is to tell the broker that I'm publishing sensor-based data, and this particular data that I'm sending is a heat reading. That gave me back an ID for the topic, and I can then use that to publish a message to the platform. So I'm going to do that here. This is using a quality of service. Hang on a second, excuse me. Yeah. Send that through. That's published into the platform now with a quality of service of 0. And that message is now being received on the platform. And if I look in my traffic logs here, I can see the messages that have been exchanged with the broker. So here's my connect, an acknowledgement back, a register of the topic, an acknowledgement back with that ID, and there's my publish. So to get that one message out with a quality of service 0, which is the fire and forget, I've had to spend all these other messages to do that and have that time on air. Now, with the use of topic aliasing that Lee mentioned, we can remove a number of those steps. So let's just clear those logs out, and we'll start again. If we look at my topic section here, I have my sensor heat topic registered on the broker, and I can assign that topic an alias. This is a simple integer alias, which I can now refer to in my client. So if I go back to my AT terminal, I can now resend that 23 degrees message, but using the quality of service -1. And if I hit send there, I get the OK response back. If I look in my traffic logs in a second, I should see the message arrive. Here it is. So this is now my MQTT publish using quality of service -1. So I haven't had to go through that connect and register step. I can just send that data using a single message, and my time on air for the device is greatly reduced, as is the data that I've had to send over the air as well. So let's have a look at how the flow manager can help you kind of improve things even further. If we look here in my flow, I'll go through and connect up pieces of this, but in its basic form, right now we're just receiving a message in and outputting it to a debug node. So if I go back into my client, I'll hit the send again to republish that message, and now we'll see here in my debug output the message has arrived, and I can see here's my message payload 23 degrees. Now the Thingstream broker also gives you a whole bunch of other metadata associated with that device. So I can see here in my message object that I have things like the device name, a serial number, when that device was first activated, a whole bunch of other information which I can now refer to programmatically in my flow. So here I've got a payload 23 degrees. That's no use to a back-end platform on its own. It doesn't know who's published it or what it's about. So what I can do is, with using one of these JavaScript function nodes here, I can save off the payload that was sent by the device and then build out a new payload, adding in the additional metadata. So here I'm going to add in my device name, the device serial number, and then bring back the saved reading that I took. And all I have to do then is connect these nodes together and save the flow. Quite a handy little debug tool in here is the ability to replay the last message, so I don't have to keep going back to my device when I'm working on my flow. I can have an original source message, or I can even send a test message myself without having a device in the first place. So let's just replay that last message. We'll see the message arrive in. Here's my original one with the 23 degrees as a string. And now I've built out a JSON object, which is built in the device name, the serial number for that device, and then added in my reading. So that's now more useful to the back-end system that I want to send it to. If you think about platforms like Microsoft Azure, if you're sending different data types like location updates and so on, there are specific kind of JSON formats that those platforms need. So this flow manager allows you to build the data into the right format for the platform you need to send it to, whereas the device only has to worry about sending the raw data that you're interested in. Again, saving all of that heavy lifting on the device side. So now I want to publish this on, and I'm going to use an HTTP endpoint, which needs a few headers. So here, another JavaScript node, I build out my my headers. I can build in the content type, and also imagine the backend system requires some kind of device level authentication. I can programmatically bring in a password to do that authentication. So if we look at my thing back on the thing list here, in the properties for this, I've defined a password type property and stored the value of the password that this device needs to communicate with the backend. So here in my flow, I connect that node up, clear my output, and save. If I replay that message again, I've now got down here my JSON object going out to the HTTP endpoint. I have my HTTP headers which are added in, and now my password has been retrieved as well from that stored value and sent on to the HTTP endpoint. And if I look at this is using Post here, which is a test HTTP service. If I go in and browse to that endpoint, then I can see the value that's been posted. So here's my device name, serial number, and reading. And over here in the headers, we can see the content type and my password that's now been sent over to do that authentication. So all of these things allow the device itself to just worry about the raw data that it needs to send, and allows the broker and the flow manager to deal with all of that kind of heavy lifting and additional data that's required for JSON and whatever backend systems that you want to connect it into. In the palette over here on the left-hand side on the flow manager, we have a range of different nodes. There are network connector nodes. You can send emails, FTP files, send SMS. So as Lee mentioned, you could add some sort of threshold logic perhaps here in one of these JavaScript nodes to say if the temperature exceeds a certain value, send an email to an engineer. If the temperature further exceeds another threshold, then send an email and an SMS as an alert to someone that action needs to be taken. We also have generic HTTP and MQTT nodes so that you can carry out functions like that. And then we also have some strong type nodes for other services. So a whole bunch of AWS nodes for dropping data into DynamoDB or calling Lambda functions or putting data into S3 buckets, as well as connectors for popular platforms like Microsoft Azure and IBM Watson. So you can very quickly and easily get your data out to these platforms, simply a case of dropping that node in, connecting it up to the point in the flow where that data is ready to publish, and then configuring it with your device connection string for Azure, which of course could be stored as a property against the individual thing in your list and then referred to programmatically through the flow. So that brings the demonstration part of this presentation to an end. We can throw back now and have a look at any questions that have come in and pick up any other points that you'd like to cover.
Great, thank you so much, Lee and Nick. Let me remind everyone that is in the audience right now, if you have any questions, there's that Q&A widget at the bottom of your screen where you can submit questions for them both. And for anyone that's listening on demand, we'll also make sure that there's a method for you to be able to reach out to them offline as well. So let's get going on some of these questions. We've had a couple of people reach out. This first one is asking about sleep and power. So can MQTT and MQTT-SN devices sleep to save power? And the second part to that is, if they do, will they miss messages as a result?
Yeah, thanks. I can pick that one up. So yeah, MQTT-SN brings in the ability for sleep mode. And in this way, the client can tell the broker that it's going away for a period of time, and it will be back. So while the client is sleeping, the broker will queue up any messages that are sent to topics that that client is subscribed to. And then the client can simply ping the server when it's ready to wake up, and the server will flush down any messages that have been queued during that sleep time. So there's no messages lost. And that works across the different qualities of service. So if there's quality of service 0 messages being published to topics that you're subscribed to, they're still kept, even though there's no acknowledgement required for delivery. The broker will queue those if you're sleeping and deliver them when you wake up.
Excellent. That's a very reasonable concern, though, doesn't it? Let's move on to this next one, which is referencing Thingstream in particular. Can Thingstream be used with non-u-blox modules?
Yeah, that's a great question. So absolutely yes. The service is hardware agnostic. So there's some quite nice features if you do use a u-blox module with that native SN client. Makes things really simple and easy. But it works with any modem. We have a client SDK that you can install on your device, which exposes some simple API methods for connecting and publishing. That SDK handles all of the MQTT protocol side of things and the communication with the modem. So yeah, absolutely, you can use it with anything.
All right, and we've had this question pop up at least twice already. Can you talk about the costs associated with Thingstream, please?
Yeah, sure. So the MQTT-SN side of things that we were looking at there is using a product called MQTT Anywhere, which is part of a suite of products that comes under the Communication-as-a-Service banner. MQTT Anywhere is priced based on the number of MQTT messages that you use. And we have a range of really simple price plans starting from 25 cents per month, which gives you 500 MQTT messages, up to $2 a month, which gives you 12,000 MQTT messages. And that price includes a global roaming connection. So we have a SIM card, which has a private secure UDP tunnel on it, or available through it, which allows you to connect anywhere in the world, pretty much. About 190 countries that we operate in, around 600 networks. The device will roam seamlessly onto those networks, so really good for asset tracking and that kind of thing where devices are moving across borders. And that price is fixed, so anywhere in the world, the same price to use. And you can find details of the pricing on portal.thingstream.io/pricing.
Perfect. All right, let's move along to, is it possible to send a broadcast type message to multiple topics or, if need be, the whole network?
So it all depends on what topics a device is subscribed to. It's possible to use wildcards in your topic subscription. So you can opt to subscribe to everything. So then any message which is published to the broker will be delivered to that client. So yeah, there are ways and means of handling that broadcast type thing. One other feature of MQTT, which is quite nice, is MQTT retained messages. This allows you to publish a message to a topic, which is then retained on the broker. And anytime a new client subscribes to that topic, that last retained message will be delivered to the client. So even though the client wasn't subscribed at the time that message was published, it's still possible to deliver those messages. And that can be really handy for things like sending config updates, for example, or notifications about new firmware. Then the client can just subscribe and receive whatever the last message was.
That's a great explanation. Thanks. And by the by, these are some really great questions. Keep them coming, guys. Let's go for this one. How much flash and RAM memory is required to implement MQTT on an MCU-constrained device?
Yeah, that is a great question. The MQTT client SDK that we provide is a very small footprint. It will run on very small microcontrollers. STM32 is a very popular controller that we use. Also supported across a number of different Arduino boards. Yeah, very, very small amount. You can run the SDK plus sort of a full-blown GPS tracking firmware on something like the STM32 and still have plenty of room to spare. Yeah, very low footprint.
All right. It's an interesting one. Is it possible to use GSM modules like VSIM 900A for MQTT protocols in Thingstream?
Yes, absolutely. So the Thingstream MQTT Anywhere SIM card will connect across 2G, 3G, LTE, the LP-WAN networks as well. Yeah, any module will work okay. We have a number of clients with that SIM 900A that was mentioned there. We have a number of clients that use that particular module in their applications.
All right, here's a pretty load-bearing question for you. How much data can be sent in a single MQTT message?
Yeah, so with MQTT-SN, it is, I need to remember now, something like 48 kilobytes that can be sent in MQTT-SN. Regular MQTT is much higher. So you're not constrained, particularly when you look at the use cases that we're dealing with here with sensor networks and M2M communication, then those MQTT doesn't really restrict you. And that works in the same way both directions. There are no restrictions in terms of how many downlink messages you can have or uplink messages. They're all handled the same bidirectionally, yeah, plenty of space there for the messages that you need to send.
All right, another really great question from the audience here. Is it possible to use your own SIM cards and operator with Thingstream platform?
Yeah, that is a great question. So we are just about to launch a new product in the Communication-as-a-Service suite called MQTT Flex. Now, MQTT Flex allows you to connect with your own SIM card. The first iteration of Flex uses DTLS on the device for the authentication and encryption. And there will be two further releases coming, one later on in Q4 this year, which brings support for MQTT Flex into the client SDK. So the first release is only supported on the u-blox SARA R5 and SARA R422 modules. The second release coming later this quarter will bring that into the SDK so that it's then hardware agnostic. And then there will be one further release at some point in Q1, which will integrate MQTT Flex with u-blox security services, which is a suite of services available on, again, those SARA R4 and R5 modules, where there's a unique root of trust ID tied to the modem. And that allows you to have a very high level of security without the need for the extra sort of power burden of DTLS. So that will be the third release of Flex coming next year.
All right, here's an applicable one, probably resonate with a few listeners here. How long can a device sleep before reconnecting? And for a little bit of context, I've never needed to say this aloud before. Is it COAP, COAP, COAP?
Yeah, COAP, yeah.
All right, so they're trying to decide between COAP and MQTT-SN because of the power requirements in particular. Okay,
yeah. So you can set very lengthy sleep durations. It can be days. So you don't have any sort of heavy restrictions there. Typically, the suggestion that we make is that you would set the sleep duration roughly in line with the expected publish frequency of the device. So if you have a device that's going to publish once a day, then you set your sleep to 24 hours. And that way, in order to maintain that sleep period, the client needs to speak to the server at some point during that window, and that then refreshes the timer. So if you keep your sleep duration roughly in line with when you're expecting to publish, that helps you, again, save some additional messages in keeping that sleep window open.
And just another little note that everyone in the audience are killing it with these great questions. So this person would like to know, so in MQTT, so TLS makes the MQTT layer secured. Which protocol can be used with MQTT-SN to make it secure?
Right, so that is an excellent question. So MQTT-SN in its own sort of bare form doesn't provide any kind of authentication or security. And the data for SN is sent over UDP, which again is not a secure channel. What we do with MQTT Anywhere is we have the SIM card provides a private UDP tunnel. So the data that you send is not exposed to the internet at any point. And we then, from the broker, have a VPN into the operator core network. And we use the identity of the SIM card as the authenticator. Now that SIM identity is provided directly by the network, the core network, so it can't be spoofed or intercepted at any point. And that allows you to actually send your data effectively in plain text from the MQTT-SN client through this secure tunnel and securely into the broker, which saves you even more power because you don't have to worry about any of the security on the device itself.
Perfect. All right, so very reasonable question here. Are there any discovery or developer boards that are available?
Yes, there are. So we're just about to launch a couple of boards through a company called Sodak. They have a couple of Arduino boards, which we have developed an example tracking application for. So these boards will ship with an MQTT Anywhere SIM card embedded on them and pre-installed tracker applications so that you can sort of out of the box be up and running and doing sort of GPS tracker. And then, of course, the source code for those sample projects is available to download, so you can then adapt and build your own applications. So that's one of the boards which is just about to come out. There are a couple of others which will be coming from SparkFun. And of course, you can use any GSM-enabled board from people like Microelectronica. The SDK that we have is available for a number of different microprocessors, so you can build your own kind of MQTT Anywhere board as well, using the modular and processor of your choice, and then just install the SDK onto it. And the SDKs come with example sort of Hello World projects on them to get you going quickly.
All right, and I would say that this question is actually quite relevant to that one, but maybe even zoomed out a little bit further. Where do you guys recommend people start with MQTT as a beginner?
Yeah, another great question. So on the u-blox website, u-blox.com, if you just go in there and search MQTT Beginner's Guide, then we have a whole bunch of information available on there. Talks more about the use of MQTT topics, what MQTT means as a whole, and how to get running with it. And then, of course, once you get into it, there's a great support team, support at Thingstream.io, who are always on hand to answer any questions that you have if you run into any problems or not sure of anything as you get started.
All right. Just a quick reminder for everybody, we're kind of winding down a little bit here. If you have additional questions for Lee and Nick here, this is a really great time to take advantage of this opportunity to talk to them directly. Let me also remind everybody that if you have had a very specific question pop up in the back end, the u-blox team is busily working in the background, so they'll be able to get to you on a more personalized basis as well. All right, so another question here for you guys. Could you please give a little bit more information about scaling up from a POC to a large-scale implementation?
Yeah, sure. So I guess that's probably talking about the flow manager. So in the example that we did in the demo there, the flow was running in a test mode, and in that test mode you can see all the debug output, and you can edit the flow and make changes to it on the fly. Once you're ready to go live, you just go into the deployment manager on the flow and switch it to live mode. Just a couple of clicks. That then redeploys that flow as a live flow. It's then locked for editing, so you can't accidentally make changes to the live flow. And that then kind of unlocks all of the auto scaling that Lee mentioned in his presentation. Basically, the way that the flows work is that when they're subscribed to MQTT topics, just like any other client, when a message comes into that topic, the flow is invoked and will execute. The flows they're Dockerized, so they have their own Docker instance. So when the flow runs, it spins up its own Docker instance. All of the nodes that are in that flow are the back-end processing for those is in Java. So a whole load of scalability behind that flow process, and the flow itself can be invoked, unlimited number of times. So you can have hundreds of thousands of devices all publishing at the same time, all spinning up their own instance of that flow to send that data through to the back-end systems. So very simple, very straightforward to go from trial to live. And of course, you can build new versions of flows. You take your live flow, click on to create a new version of it, so that you can then have that instance of the flow deployed in a test mode, so you can work on adjustments and new features for your flow without affecting the flow that's already live. And then once you're ready, you just promote that test flow back into live mode, and that will automatically replace the existing live flow with the new one. So yeah, very, very simple, straightforward process for doing that.
That's a great, thorough answer. Thanks so much for doing that. And we're just going to give everyone just one more minute to submit any last-minute questions. So let's take this opportunity to ask you guys, is there anything else that you guys would like to share with our audience? Anything else that you think would be helpful for them to have in their back pocket as they move forward?
Lee, any thoughts on that one?
Yeah, there was a couple of tools you used there for sending and testing messages that I think would be good for people to have in your arsenal, Maybe you could mention a bit about those.
Yeah, sure. So the tool that I was using there with the sort of the AT terminal emulator is called uCenter. That's a u-blox tool, which we put together to help you sort of work with u-blox modules. Of course, you can use it with any module. It's just getting a serial connection to the modem and then sending AT commands to it. So that's a really, really nice tool for Windows users to get hold of. There's also in the portal itself, the Thingstream portal, the ability to send test messages. So anyone who has a look in there, you'll see, once you create a thing in the platform, then there's a menu option there to send a test message. And that will then allow you to send test messages, on behalf of a device. So as far as the broker is concerned, that message appears to have been received by the device, but you don't need the physical device to do it. And then, of course, those debug tools in the Flow Manager itself, which allow you to replay the last message. You may have noticed on the palette there in the Flow Manager, there's also a node there for a Thingstream inject, which allows you to inject messages at any point in the flow. So when you're working on that kind of debug side of things, you can take the format of a message as you would like it to be at a certain point in the flow, drop that injector node in, and then trigger a flow from that point of the flow onwards. So yeah, quite a few nice developer tools in there to help you debug and work with your proof of concept while you get it ready for going live.
All right, it does look like we have one more question under the wire here, if that's all right with you guys.
Yeah, sure.
Acting on data for Thingstream, they'd like to know more about basically what that process looks like. The example is that they're measuring pH from water. They want to check on the threshold parameters of that pH, and when it will cross that threshold of the pH value, it'll turn on an AC load.
Okay, yeah.
Talk a little bit about that? Mm-hmm.
Absolutely, yeah. It's a really good use case, actually. So if you're looking at the Flow Manager, you would have one of those JavaScript function nodes, which is looking at the values that are coming in from the device. And then you can build different outputs. So as part of the configuration of that node, you can say how many outputs you want that node to have. So you could have, if the pH level is just, a regular point, take no action at all. If it gets to another level, maybe send a message to someone, and then if it goes over a threshold, turn on this AC load. And the way that AC load would get turned on is by then connecting that particular output part of the function node to another MQTT publish, which would publish a message to a topic that device is subscribed to. And in doing so, can then send that message to tell it to turn the device on. And you can, of course, use unique device IDs in your MQTT topic structure, which allow you to then address specific devices with specific messages rather than sending something to everyone on a generic topic.
That's awesome. Thank you so much for going through that thought experiment. Really great way to wrap up the Q&A. I just want to mention, great questions, great answers. This was a really awesome Q&A session. So as we wrap up here, let me do the announcement for our live session giveaway winner. Congratulations to Todd Zagumni. Todd, congratulations. We will be reaching out to you and make sure that we get that prize package into your hands as soon as possible. And with that, let me just remind everyone, you will have access to this entire presentation on demand this week, so keep an eye out for that. And I believe that just about does it. I just want to say thank you to you, Lee and Nick. This has been absolutely wonderful. Really great information, very thoughtful answers to our audience questions. And also thank you to u-blox. This is a really interesting topic. I think it's going to be interesting for quite a long time now. So I think that just about does it. Lee and Nick, you guys good?
Yeah, all good. Again, I just echo that. Thanks for the questions. That was a really, really good interactive session and some excellent questions there. So thanks, everyone.
All right, and with that, just a quick plug. In 15 minutes, we have our Day 3 keynote with Brandon Moak of Embark talking about autonomous semi-trucks. They basically came up with a concept for an autonomous golf cart when they were in college, and it's a crazy story. So if you're interested, 15 minutes from now, that's our next keynote, and that basically does it for the first live session of day 3 here at Industry Tech Days 2021. Thank you, everyone, for joining. We will see you at the next one. Have a great day.